Okay, this back page is a little bit tougher. We'll talk about each one and what we need to look at. So when I see this one, I see two different trig functions, but I can put cosecant in terms of sine. So I would write this as the sine of theta equals 1 over the sine of theta. So it's kind of like having x equals 1 over x. How am I going to solve for x? I'm going to multiply to get rid of that in the bottom. So I'm going to multiply both sides of the equation by the sine of theta. So I'm going to get the sine squared theta equals 1. So to solve that, it's like having x squared equals 1. I have to take the square root of both sides, but remember it's plus or minus the square root of 1 on that side. So I get the sine of theta equals plus or minus 1. So where on the unit circle is the sine, the y value, equal to 1 or negative 1? Two places that happens. It's equal to 1 at pi over 2. It's equal to negative 1 at 3 pi over 2. So don't forget, when you take the square root, you have to think about the plus and the minus of that answer. So you get two answers there. All right, so let's look at number 8. 8, I've got this 2 theta in there, so I probably want to use that trig identity again. The trig identity we want to use is that sine theta, 2 theta 1 is 2 sine cosine. So I'm going to use that, 2 sine cosine, but that's still times the sine. So all I did is replace this piece with 2 sine cosine. So we can multiply those together. We get 2 sine squared theta cosine. So at least now we have everything in terms of just theta. And we have two terms. So again, before we can factor this, we've got to set it equal to 0. With two terms, they have something in common. I can factor out the cosine of theta. So here I get 2 sine squared, there I get a minus 1. Set each of those equal to 0. So I get cosine is 0, and that's going to happen. Cosine is the x value is 0 up here and down here. So that's going to be at pi over 2 and 3 pi over 2. This one I add 1 divided by 2, I get the sine squared is equal to 1/2. So if I take the square root of both sides, I'm going to get the sine is equal to plus or minus. When I take the square root of 1/2, I'm going to get 1 over radical 2, because I can take the square root of the top, square root of the bottom. If I rationalize my denominator, I get the sine of theta is equal to plus or minus radical 2 over 2. So where is the sine equal to positive or negative radical 2 over 2? Well, it's going to be equal positive radical 2 over 2 on those quadrants, negative radical 2 over 2 on those quadrants. Those are all 4 angles, have a reference angle of pi over 4. So theta is going to be pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. All 4 of those because of the plus or minus in all 4 quadrants. Okay, so that question had 6 answers to it. All right, number 9. 9 is a sine and a cosine, so there's not a lot you can do with that sine or cosine, but what we could do is what we did in the example class, is we could square both sides. Now, I might be adding an answer, so I have to make sure I check my answers when I'm done, but that's a technique you can do. If you have an equation, you can square both sides. So I'm going to get, when I square this binomial and multiply it by itself, I'm going to get sine squared theta. My inside product is going to be 2 of these sine cosines plus cosine squared. And on the right side, I just get 0. And then I see that sine squared plus cosine squared is 1. Now, I can't factor this. Like, these two terms have nothing in common. So at this point, it didn't really help me. I could try to subtract 1, divide by 2, but I really wouldn't have anything that I could work with because I still have the sine and cosine. So here's what I would do is I would take this now and work backwards and say that, okay, from our trig formula sheet, I know 2 sine theta cosine theta is equal to this 2 sine, or sine of 2 theta. So now I'm going to go backwards and say that all of this has to equal the sine of 2 theta. So I'm still using that formula, but kind of the other way. So 1 plus sine of 2 theta. Because now I have it in terms of one trig function. So I can say the sine of 2 theta equals -1. Where is the sine equal to -1? That happens down here. So because it's a 2 theta, I'm going to say 2 theta equals, that answer is 3 pi over 2 plus 2 pi k. Remember, if there's a coefficient, I have to say plus 2 pi k. And so when I divide by 2, I'm going to get theta equals 3 pi over 4 plus pi k. So my answers when k is 0, if I put in k as 1, if I take 1, which is 4/4, plus 3/4, I get 7/4. So that gave me 2 answers to that one. I do have to double check, plug it back in up here. If I take the sine plus cosine, I have to get 0. Let's check to see if that works. At 3 pi over 4, which is over here, if I take, and both of these, my reference angle is pi over 4, so it's negative radical 2 over 2, radical 2 over 2. If I add the sine and the cosine together, I get 0. Over here, the x value is positive, the y value is negative. When I add them together, I get 0, so they do both work. But you do have to check that because you squared both sides of the equation, you always have to check your answers. Alright, and then the number 10, I have a tangent and a sine, so I probably again have to get this in terms of sine and cosine. So tangent is sine over cosine. Let's multiply by cosine to get rid of that in the denominator. And now, again, I have two terms, so we set it equal to 0. Get minus sine theta. Factor out my common factor of sine. And now I set each of those equal to 0. So you start to see a pattern. These all kind of start to look a little bit similar. Sine is 0. Sine is the y value. Y value is 0 here and here. So that's going to happen at 0. Remember, we have to name this 0, not 2 pi. And then over here it's pi. Here I get the cosine of theta is going to equal, add 1 and divide by 2, so 1/2. Cosine is positive here and here. Reference angle would be pi over 3. So it's pi over 3, and if I go all the way around the circle, that would be 5 pi over 3. Are my two answers there. So with that one, you just had to put tangent in terms of sine and cosine. To get rid of that cosine in the denominator, we multiplied by cosine theta. And then once I see I had this, it was back to those. Let's get a 0, and then let's factor out the common factor. Okay, and then the last two real quick, we just have to use your calculator for. So just put those into your calculator. So I think I already put those first two equations in my y equals. y1 I put as, this is y1, so that's x squared. This is y2, and I just want to see, when does y1 equal y2? When do they intersect? So I'll put those in my calculator, make sure you're in radian mode, and I'm going to go to the standard window, so I'm going to hit zoom, and go down to zoom standard number 6. There's x squared. Here's the second function. I just need to figure out those two places where they intersect. So second calc intersect. First curve, it says, and that's my x squared, yep. Second curve is this equation, yep. And there's two answers, so you have to get close to each answer. So I get close to the first one, I get an intersection point when x is negative 0.93. I'm solving for x. I don't need to worry about the y value. And then the other place, second calc intersect, first curve, yep, whoops, sorry, second curve, yep. So I'm just looking at this, yep, second curve, but now I need to arrow to closer to that solution. And I get an answer of 1.39. So that's negative 0.93 and 1.39. Those are the two places where those two graphs intersect. All right, and then real quick before I run out of time, do the second one. For my y equals, I have a sine x plus cosine x, sine x, close that parentheses, plus cosine x. And then this one was just x. Zoom standard again. There's the sine plus cosine. And here's the y equals x. Looks like they're only going to intersect in the one spot, so second calc intersect. First curve, yes. Second curve, yes. And let's get close to the guess. I get an x value of 1.26. And only one solution to that one, again, by looking at that graph. Okay, so that's just putting one thing into y1, put the other into y2, and see where they intersect. Okay, so that's page 2.